Hello, everybody. Welcome back to Monte Carlo Methods. In today's short video, I'm just going to get you up and running in R. Actually, that's a lie. I'm going to ask you to get up and running with R. So download it if you haven't already at r-project.org. And you may download it for Windows, Mac, or Linux. And also, you may figure out a different interface you'd like to use other than the one I'm using here. I happen to be in Windows, and this is the basic interface you get. But there's something known as R Studio, which can make things a little nicer. To be honest with you, when I use R in my research, I am usually in Linux using just a blank bare bones terminal. And because I don't know what you're going to be using, and because I know nothing about Macs, for example, I am going to do everything in these videos that I'm doing in R, just in using the command line. So I'm not going to use any menus or buttons that might be in one interface versus another. So there's sometimes easier ways to do things than how I'm going to be doing them for you in these videos. Okay, so assuming you have R open, let's go. I don't, I'm not going to require you to know anything about R. We're going to do this from the ground up for Monte Carlo. So not from the ground up for learning R, because there's a lot of things I would do first if this was a course in R. But I'm trying to minimize the impact of having to do a second course here in R. So I'm just going to do what you need to do first to get into and through this course. We have recently talked about random number generators, and I'm going to start off by generating a random number using the built-in default random number generator in R, which as of the filming of this video is the Mersenne twister, but it's unimportant for what we're doing here in this entire course. So if you are using simulation and Monte Carlo methods in your job or in your research and you're doing something particularly sensitive, maybe you want to think about your random number generator, but I don't want to think about it anymore in this course. So in this window, I'm going to generate a single uniform, and I'm going to do that by typing runif, which I imagine stands for random uniform, open parentheses, the number 1, and close parentheses. I'll tell you what that 1 is in a moment. I'm going to hit enter, and there, I've got a number, and if you're following along, you should not have the same number in front of you, because that's just how randomness is. The 1 here was used to say, I want one random number. This function runif can take other arguments that we'll eventually talk about, but if you just put in one integer argument, that's what it's going to be. It's going to be the number of random numbers to give you. For example, if I typed runif 10, I get a whole vector of values from the random number generator. And if I'm going to want to be manipulating these values, like maybe making a histogram or going through and counting things like how many values are above 0.4 versus below, or looking at runs up and down, which is something we're going to do in the next video when we start to talk about tests for randomness. And, we don't want to see, not only do we want to see uniformity, but we don't want to see any word correlation between the numbers. So anyway, if I'm going to want to be manipulating these, then I need to name this vector. So to do this, I actually am going to just drop this vector. I'm going to, as I name it, I'm going to create a new one. There's definitely a way to grab the last value in R, the last thing that was computed, and name it, but that's a little more than I wanted to talk about today. So I'm going to call my vector U for uniform, and I'm going to do something that may look a little weird here at first. Please let me finish the line and explain. So I've created a vector of length 10 of values drawn from the random number generator, and I've called it U. If I type U, you can see the vector pop up. And because I invoked this function for a second time here, I do not have the same vector as I had up here. It's not important for what I'm trying to do today, so roll with it. But yes, there is a function called last value in R that will allow you to grab the previous vector generated, which is totally unimportant. Okay, so what about this line here? There's two things I'd like to point out. One is this arrow I've drawn with a left caret and a dash. This is an assignment operator in R, and it is unnecessary. If you want to use an equal sign, you will get the same result that I'm getting, and you will assign this vector of values from the random number generator to something called U. So again, you can replace this with an equal sign. Back in the day, before R was R, it was actually S. So you would think they would have called R T or something, but I digress. Yeah, I've been using S, S plus, and then R, which are essentially all the same thing for over 30 years. And back in the day, this assignment operator was something different than using an equal sign. Today it is not, but I'm kind of an R purist, and so I like to use this assignment operator. It's up to you. Another thing I'd like to point out about the line I typed is that I have spaces in here, and that is just to maybe make it cleaner for a video. If you're working as a programmer for some company, it's often good practice to put spaces in. Honestly, I don't do it if I'm coding for myself. It's just here. Space is unimportant. If you're used to coding in, say, Python, sometimes space can be important, especially if you are continuing several lines of code and you need indentation on your second line. Sometimes it's super important to have spaces or not have spaces in other languages, but in R, it doesn't matter. So one more time, if I just wanted to do, say, U and then an arrow, R unit 10, that would be fine. If you wanted to use an equal sign, that would be fine. If you'd like to add some space, that is all fine. But yeah, I'm going to leave it right here. So before making a histogram, let's just talk about accessing these values. I'm going to access the first value or look at the first value by typing U, open square brackets, 1, and closing the brackets. The point I'm trying to make with showing you this is that R uses indexing for its vectors starting from 1, as opposed to something like Python that uses zero-based indexing. So you might think that I should have typed U of 0, depending on if you have any sort of background in programming. R does use indices starting from 1 for its vectors. If I'd like to look at several values, say 1 through 5, then I'm going to use a semicolon here, and that will grab the first 5 values of this vector. There are other ways to do this. There are head and tail commands if you're used to stuff like that, but this is all we need in here. By the way, if you were just type 1 and then :5 out here, you can see what happens. It's producing a vector with the values 1, 2, 3, 4, 5. So in this line up here, I am plugging this entire vector in to say, these are the indices I want to look at. So let's go for that histogram. I really don't want to make a histogram of these 10 values. We could do it. We could look at it for a laugh. But I think I've given you the example already of flipping a coin. I'm not sure if I gave it. I'm sorry if I'm repeating myself too much. So if you have a coin in your hand and you want to know whether it's fair or not, are you going to flip it 3 times, 4 times, even 10 times? Are you going to be really happy with those results? What I want to do today is begin testing our random number generator. And you might as well, if you can, get a whole lot of values so that you can really see what's going on and really see if there's a problem that's not just based on you getting a funky little weird sample like you might get by flipping a coin only 3 times. So to this end, I am going to generate a new vector U, and I am going to generate 100,000 values. I don't know, that's the number I like to work with when testing my Monte Carlo algorithms. Sometimes you can't because when the algorithms become more complicated, things are slow, but that's not going to be an issue here. If I typed U, all of these numbers would run up the screen right now, so I'm not going to do it. But if you want to take a look at some of them using the commands that we talked about up here, you certainly could do that. Now, to the histogram. The simplest way to do this, which is not going to be enough for us, but would be to just type hist, open parentheses, U, and close parentheses. Another window should pop up depending on your interface with a histogram. Now, there's 2 things I really don't like about this histogram. One is that the y-axis by default has frequency or count data. So it has made some bins for us, which is the second thing I don't like. I'll get back to that in a moment. But this is saying that there are 4,900 and something, whatever this number is, in the first bin. And the first bin here seems to be between 0 and 0.05. Just, going up to 0.2, I've got 1, 2, 3, 4. So dividing by 4, 0.05. This is saying that out of my 100,000 values, there are whatever this number is, 4,988, I'm just making this up, values between 0 and 0.05. We've already talked about wanting to use density on the y-axis so that we can compare our histograms with PDFs so that area of the boxes represents probability, and that would match up a PDF under which area under the PDF represents probability as well. So to fix what's being used on the y-axis, I'm going to go back over here to this window. I guess I should have mentioned this already. If you're going to redo a command and maybe add to it, you can hit the up arrow. You can hit it as many times as you want, and it'll go through the previous things you have typed. You cannot, by the way, go up here and add something to a line. Once the line has gone by in R, you're done. We can talk about ways to deal with this for more complex programming. Eventually, we're going to talk about writing all your commands in a script and running it at once so that the commands are not lost to you forever as they roll up the screen here. But I'm going to hit the up arrow once to get that hist command again. I'm going to go back in the parentheses, hit comma, and then type prob for probability equals and a capital T for true. So you can see over here that the y-axis has changed. At least the word has changed from frequency to density, but that's not the only thing that has changed. The numbers used to go up to 5,000 and now they only go up to 1. So we have density on the y-axis, which we discussed in the first video. The other thing that I don't like about this histogram is that it actually is a fine looking histogram, but I like to be able to control the bin width, and it has chosen a bin width by default, which appears to be 0.05. This looks pretty good, actually. If the bin width is too wide, then the histogram is going to be very weird and chunky, and you're not going to be able to match a PDF very well. And if your histogram bars or bins are too narrow, then you could easily find, if you go very narrow, like if you try to subdivide these into 50 or something, then you might find a tiny interval somewhere here that doesn't have any values in it and one next to it that has a lot of values. So you'll start to see holes in the histogram with big weird spikes. I'm not trying to encourage you to quote unquote lie with statistics and just make it look how you want to look, how you want it to look, but you want to strike a balance between super chunky and super, super fine. My preferred value most of the time is to have a bin width of 0.1. That would not make sense at all, depending on what kind of data you're looking at. That's usually my default, except if I'm looking at data that's going to cover a very wide range of values. So when I say my default, I mean that's usually my default for taking a first look at a histogram and figuring out if that's a good looking bin width. Let's just say, for the purpose of knowing how to make our own bins, that I do want the bin width to be 0.1. As I already said, I think the bins look okay as they are, but let's try that. I'm going to go back over the window and I'm going to make a vector of sort of bin endpoints. I'm going to use BR for breaks. You can call this whatever you want. I'm going to assign to it a sequence of values. And I'm going to use a command seq for sequence that takes 3 arguments. My starting value of 0, my ending value of 1, and then a number that represents how much distance there is between each number in the sequence. So I'm going to use 0.1. Let's take a look at my breaks vector. You can see it's 0, 0.1, 0.2, 0.3. So these are going to be the endpoints for my histogram. Now I'm going to hit the up arrow till I bring up that last histogram command. And I'm going to go back in here and put in a comma and say breaks equal, and then I'm going to put the vector I called BR. So now you can see what happened in the picture. I've got wider bins. Again, it wasn't necessary for this picture. I think it looked pretty good the way it was, but you should know how to control your bin width for the future. As a final thing before throwing a PDF on here, let's get some color going. I'm going to go back into the command window, hit up arrow, and I'm going to get inside these parentheses, comma, and then COL for color equals. I'm going to use a built-in color in R. You can create any color you want by providing RGB values. We'll talk about that eventually. But I'm going to choose the color light blue. I am going to use quotes. Light blue. Close those quotes. You can see what happened over here in the picture. As a final thing for today's video, I'd like to put the PDF on top. In other words, I'd like to superimpose the PDF on this histogram. Because the PDF in this case is just a flat line, I can easily define it with just 2 points. I'm going to, in the command window, type the command lines, open parentheses, and I'm about to add a line to this graph. When you type this, it will add a line to whatever your current graph is. If you had multiple windows with graphics, that's something we'll have to deal with eventually in this course. But I'm just going to type lines, and then 2 vectors with x coordinates, 1 vector with x coordinates and 1 vector with y coordinates. You define a vector in R with the letter C. Let me back out of this command. If I type a C, open parentheses, and then just put some numbers down, that's how I make a vector with this letter C. And I could have given this vector a name like we did with the uniform sample so that I could refer to different elements. But I'm going to use this C in my lines command. So back to lines. The first vector is going to be all of the x coordinates that I would like. Basically, I'm going to define 2 points, and the lines command is going to connect them. I could actually define a whole lot of points in this command and have them all connected by lines as well. But let's just do what I'm trying to do. Let's just get this over with. My x coordinates are going to be 0 and 1. And my y coordinates are going to be 1 and 1. So these do not represent an x and y coordinate and an x and y coordinate. No, these are both the x coordinates for 2 points and both the y coordinates. When I hit enter, we've got a line on top. It may be a little hard to see, so I'm going to do it again. I'm just going to write over this line, and I'm going to add a comma and type LWD to change the thickness of this line equals, say, 2. So that has made a slightly thicker line, which is maybe a little easier to see. So that's all for today. Just wanted to invoke the random number generator and make a histogram. You know what? Let's change this title while we're here. Oh, in order to do that, I need to regenerate the whole thing. So I'm going to up arrow until I get that hist command. I'm going to go back in these parentheses, hit a comma. The title is controlled by a command or a variable called main. Main equals, quote, my first histogram. Up arrow to get that lines command back. And we're done. So when you come back, if you come back, we're going to start testing whether or not this is a good histogram. By eyeball, this looks okay, but we're going to get into some formal tests that you can use not only for the uniform distribution, but for other distributions that you're eventually going to be sampling values from. So I hope to see you in the next one.